Uh, Good evening, Divya. We will wait for just 2 minutes and then we will start our class. So you're attending 6 to 7 session today. There was 6 to 7 session also. Good evening, Pranoy.
Good evening.
We'll just wait for 1 more minute and then we'll start our session.
Yes, ma'am.
So we'll start. I'm Anu. I'm pursuing PhD from University of Hyderabad. I'll start sharing my slides. Slides are visible.
Yes, ma'am.
Okay, fine. So last class we studied a little bit about bioinorganic chemistry. We started with metal ions in biological system. There are bulk metal ions, sodium, potassium, magnesium, calcium. Then trace metal ions, iron, copper, zinc. Ultra trace metal ions, manganese, molybdenum, cobalt, chromium, vanadium, nickel, cadmium, tin, lead, and lithium. So we started with that question and then we did some calculation questions where just by knowing adenine always binds with thymine with 2 hydrogen bonding, guanine always binds with cytosine with 3 hydrogen bonding. We could solve one entire problem. And then we moved on about learning about cobalt containing cobalamines like vitamin B12, which is cyanocobalamin, coenzyme B12, adenosylcobalamin, and also about methylcobalamin. And also we learned about amino acids, proteins, which are made up of amino acids, primary structure, sequence of amino acids, secondary structure, which can be alpha helix or beta pleated, tertiary structure, fibrous, globular, and quaternary structure. And when we were talking about quaternary structure, we told about hemoglobin, right? Hemoglobin or whichever protein that has more than one helical chain, we can tell that it has quaternary structure. And this class we will be learning or dealing basically with hemoglobin, myoglobin, and also about hemocyanin. Okay, three things, just three things. We won't get confused. And totally we will have 6 questions. Okay. And one more thing I wanted to tell you is that last time somebody raised their hand. So I couldn't see because once I start presenting the PPT, I can only see PPT. I can't see anybody raising their hands. So feel free to interrupt me in between and ask me questions. There is no issue. Okay, you can ask me questions stopping me. There is no issue. Maybe because I might miss you raising your hands. Okay. So let us move on to learning about hemoglobin, myoglobin, etc. Last time the cobalt containing ring system was corine ring system, right? So this time the ring system is porphyrin ring system. So in this time we will learn about these ring systems are important because they might ask what is the ring system in vitamin B12. So that we learned last class, which is corine ring system, and this class hemoglobin or myoglobin or chlorophyll, everything contain porphyrin ring system. So porphyrins are basically derivatives of porphins in which four pyrrole rings, these are pyrrole structure. So four pyrrole rings are joined together by methane bridges, that is CH double bond, that is called as methane, METHINE, methane bridges. And on the porphyrin ring, there might be substituents and we will get porphyrin structure. So in iron, has a very important role in our body. Iron acts as oxygen carrier, hemoglobin, oxygen storage, myoglobin, or electron carrier, cytochromes, and also present in many enzymes like peroxidase, etc. Okay. So this porphyrin, some important things that we should learn is that in porphyrin, there are charge transfer, pi to pi star, and intra-ligand charge transfer, and normally it will be in green color. And the important thing is that if like this class is based on 1 mark question, 2 mark question, like that, gate chemistry, right? So we will be dealing basically the important points that might be asked in the question, not completely into theory. So in porphyrin structure, as you can see here, there are 11 double bonds. That means totally 22 pi electrons. But the bonds marked in red, no, these two bonds will not participate in resonance, and therefore only 9 bonds participate in resonance. It will follow 4n plus 2 pi electrons and Huckel's rule, and it will be aromatic in nature. So the questions will be asked mostly in bioinorganic chemistry. Questions are asked in peripheral kind of things because we are basically chemistry people, no? So we will be dealing with that kind of things through our session now regarding hemoglobin and bioglobin. Whatever there is chance to ask, mostly we will be dealing with that. Okay. So now in porphyrin system, we can see 2 hydrogen atoms. Okay. So if these hydrogen atoms are replaced with iron, then we will get heme. In chlorophyll, this is just replaced with Mg, magnesium. So if in chlorophyll, if they are asking it is magnesium, in heme, hemoglobin, myoglobin, etc., it is replaced with iron. And when it is replaced with iron, the color becomes red. Iron 2 metal to ligand charge transfer, and iron 3 ligand to metal charge transfer will be there. And some important things are NMR, IR, and electronic spectra we will deal with now. So it is very easy. By seeing this big structure, don't get panicked. So because here are only 3 types of hydrogens. If we see hydrogen, all these hydrogens here, these are all one kind of hydrogen. Okay, these hydrogens are called as mesohydrogen. Okay, mesohydrogen, and these hydrogens are at beta position. It is called as beta position. So like that, we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So 1, 4, 8 hydrogen, that we will get at around 8.1 ppm. So this hydrogen we will get at around 8.1 ppm, and for mesohydrogen, that is 4 hydrogens are there. For 4 hydrogens, we will get at around 4.3 ppm, and these are highly shielded one. This we will get at negative 2.1 to negative 2.3 ppm. So right side to TMS. So these only 3 signals we will get. If it is further substituted, you have to count according to that. But otherwise, if they are asking for porphyrin ring, these only 3 NMR signals we will get, and that are at minus 2.1, 8.1, and 4.3. 3 signals. So this is all about NMR. Okay. Now, if we are going through IR spectrum, we have one important peak of NH, that is around 3300 to 3400 centimeter inverse. 3300 to 3400. Note this value somewhere because 1 mark question or 2 mark question, this can be asked. How many signals are there, or what IR spectrum, if they give the value and all, you should know. And the other thing, important thing, is electronic spectroscopy. So in here, we have sigma bond, pi bond, and non-bonding. So if I draw, for example, if we have like levels, sigma, pi, n, pi star, sigma star. We know sigma to sigma star can happen, pi to pi star, n to sigma star, and n to pi star. 4 transition can happen. Sigma to sigma star, okay, pi to pi star, n to sigma star, and n to pi star, 4 transition. And the energy will be sigma to sigma star, energy will be high, then n to sigma star, then pi to pi star, and then n to pi star. These are the order of energy. So the most favorable transitions will be the least energy one, that is the last two, n to pi star and pi to pi star. So we will have 2 peaks in the electronic spectroscopy, this one and small one, and this is called as, this is due to n to pi star, and this is called as Q band, and this one is called as SORET. If they give you the spectrum and ask which one is due to which one, you should know. So that's why we are dealing. No need of knowing the theoretical basis and all the things. Just you should know this is SORET, this is Q band, pi to pi star, n to pi star. Okay, because these questions are asked in 1 mark or 4 mark. If they are asking, means it will be mostly pairing and all. Okay, so you should know the peripheral things, whatever that can be asked. Okay, these are the things related to NMR, IR, electronic spectroscopy. Now, what will happen to our porphyrin ring in presence of acid and in presence of base? In presence of acid, H will come here. Okay, H here plus. Okay. Dication porphyrin ring we will get. And in presence of base, this hydrogen will be removed. This hydrogen will be removed, and we will get dianion porphyrin. And when dianion porphyrin ring is interacting with metal, we will get metalloporphyrin. So if we see this structure, if they ask, for example, porphyrin ring, if they ask how many NMR signals are there, we will tell 3, right? So if they ask like porphyrin ring is in the presence of base, then how many signals are there? That time this hydrogen is not there. So only 2 types of hydrogen are present. So in that case, the number of NMR signal will be 2. Okay, so you should think like this and then answer such kind of question. And also one question I have seen in one paper is that how many 5-membered ring and how many 6-membered ring are present. If a metal is present, like for example, if metal is there, metal is coordinated with like this. Okay, so if we see 1, 2, 3, 4, 5, 6. This is a 6-membered ring. Similarly, this 1, 2, 3, 4, 5, it is a 5-membered ring. So we have totally 4 5-membered ring and 4 6-membered ring in the porphyrin structure. Okay. Now we know about porphyrin, what it is, what is the color, what is heme when iron is attached. That time it will become heme and color will change from green to red. Now these many basic things are over. Now if we are moving on to the structure of myoglobin, first we will learn about myoglobin and then we will go to learn about hemoglobin. Hemoglobin is basically tetramer of myoglobin. Myoglobin is a protein, myoglobin is a protein that is located in our tissue or muscles, which is used for oxygen storage. The function of myoglobin is oxygen storage and is present in tissue. So these are all are important points. Now, myoglobin contain a heme group, meaning iron is present and a porphyrin ring is present. And the molecular weight of myoglobin is 16,500. Okay, and when it comes to hemoglobin, we will see the counterpart. Okay, where hemoglobin is present, what is its function, and the molecular weight will become 4 times of myoglobin, because its structure is almost like a tetramer of myoglobin. So we should not get confused. First we will learn about myoglobin, and then we will move on to learning about hemoglobin. So now, present in tissue, oxygen storage, heme group is present. The molecular weight is 16,500, and it has 153 amino acid in its chain. Okay, and in some organisms, if there is a high concentration of these proteins, it helps to hold their breath for longer period of time. Okay, now we have to learn about two things basically: deoxymyoglobin and oxymyoglobin. What is the oxidation state of iron, the geometry, etc. So now, in both deoxymyoglobin as well as oxymyoglobin, iron is in +2 oxidation state. When it comes to hemoglobin, it will differ. So you should be careful. In myoglobin, there is no confusion. In both my oxy state and deoxy state, iron is in +2 oxidation state. One thing is clear. And the shape is octahedral. Octahedral, it will be connected to 4 nitrogen of porphyrin ring, 1 nitrogen of histidine residue, and 1 will be connected to either oxygen or water. So this is also same, octahedral. And the electronic configuration, if Fe2 plus means electronic configuration is both D6, but the arrangement will be different. How? In deoxymyoglobin, it is a high spin complex, and in oxymyoglobin, it is a low spin complex. As you can see here, it is paired, and here this is not paired. This is very important. Many questions will be asked, has been asked, with the difference of oxymyoglobin and deoxymyoglobin just based on its spin, high spin, low spin. So these things are important. Both are Fe2 plus octahedral, but in deoxy state it will be high spin complex, and in oxy state it will be low spin complex. Okay, so now it is high spin means there are unpaired electrons. That means it is paramagnetic and it will be ESR active. So if a question is asked like how you will differentiate oxymyoglobin and deoxymyoglobin, so you can differentiate it by ESR. One will be ESR inactive because here all the electrons are paired, and since it is paired, for ESR there is need of unpaired electron and single electron, and here since all electrons are paired, it will be ESR inactive and this will be ESR active. And one more thing is that oxygen will be attached as superoxide form. Superoxide form, whether it is myoglobin or hemoglobin, it will be attached in as a superoxide form in both the cases. O2 minus. These many things are important regarding myoglobin. Okay, now if myoglobin is done, if it is clear, we will go to hemoglobin, because now the counterpart will come and we might get confused. So if any doubt is there, you can stop me and ask me. Now we will go to hemoglobin. Okay. In hemoglobin also, if we go, it is also an iron containing metalloprotein. Oxygen, there in myoglobin it was oxygen storage, whereas here it is oxygen transport. And there was only single heme group in myoglobin, whereas here there are 4 heme group. So that means the weight also will be almost 4 times. That means the weight there was 16,500. Here it is 64,500. And here there are 2 alpha and 2 beta helical chain, alpha 2, beta 2. And in alpha chain there is 141 amino acid, and in beta chain there is 146 amino acids. These all numbers are important because in question they will ask basically where we will get confused. They want to know that only. Last time also we saw, like if they are asking about like coenzyme B12, the other options will be methyl or cyanide group, etc. But it is adenosyl. Wherever we get confused, there they will ask question, and that confusing answer will be there in the option. So please note this, the molecular weight is 64,500, 2 alpha, 2 beta, 141, 146 amino acids are present. And now the geometry is octahedral. Now we will learn about the difference between deoxyhemoglobin and oxyhemoglobin. So in the case of myoglobin, we saw both were Fe2 plus. So there was no confusion, Fe2 plus octahedral. But here in deoxy case, the um, Fe2 plus state it is present, whereas in oxygenated form it is in present in Fe3 plus. Okay, and both everything is in octahedral form. It will be attached similar to the last case for nitrogen of porphyrin ring, one histidine and one with oxygen or water, whichever it is attached to. Okay. And in whatever myoglobin or hemoglobin, in oxygenated state, it will be a low spin complex. And in deoxygenated state, it will be high spin complex. Because mostly questions are asked based on this spin. Many questions are asked based on this spin and magnetic property. So, in whether it is oxyhemoglobin or oxymyoglobin, the spin is low, and deoxygenated state, the spin is high. We can find unpaired electrons. In this case also, there is one unpaired electron is present, but still it will be diamagnetic. This is paramagnetic. So why this is diamagnetic? So both oxymyoglobin and oxyhemoglobin are diamagnetic, and deoxyhemoglobin and deoxymyoglobin are paramagnetic. So why this is, even though one unpaired electron is present, why this is diamagnetic and ESR inactive? Due to antiferromagnetic coupling. Antiferromagnetic coupling means if one unpaired electron, one ion has, that spin will be cancelled out by the spin of another electron from another ion atom. So these two ion atoms, electrons, will cancel the spin of each other, and then the total spin will become zero. And thus it will become diamagnetic, ESR inactive, and this is called as antiferromagnetic coupling. Antiferromagnetic coupling. This can be asked. So you should know what is antiferromagnetic coupling. And in both the cases, oxygen is attached in O2 minus superoxide form, and the oxidated state is called as relaxed state, and deoxyhemoglobin is called as tensed state. Okay, this much, if this much things are clear, you can ask me. Okay, you can stop me and ask me. These are like uh, direct questions they will ask mostly. When I will take the questions no related to hemoglobin and myoglobin, I have found 4 to 5 questions. So in that all questions, you will understand that these questions are pretty direct, and there is nothing like calculation based or no, nothing like that. So pretty straightforward question they will ask. You should know the fact. If you know the fact, you will get 1 mark or 2 mark very easily. Just you have to tick. If you don't know, don't answer it, because you can't guess such kind of answer. There is, these are facts. Okay. Now we will learn how oxygen is transported by hemoglobin. So we have two things, hemoglobin and myoglobin. Myoglobin stores and hemoglobin transports oxygen. And one myoglobin can store one oxygen molecule, whereas one hemoglobin can take 4 oxygen at one time. This also can be asked. 4 oxygen per hemoglobin, 1 oxygen per myoglobin. And myoglobin has more affinity to oxygen than hemoglobin. If they ask a question like that, which one has, or statement true or false, myoglobin has more affinity towards oxygen than hemoglobin. Okay, these things are clear. Then so what will happen? Now let us see what will happen in during oxygen transport. First, hemoglobin binds oxygen to its iron atom. It binds oxygen, and from lungs it will carry to muscles and delivered it to myoglobin, where muscles, that it requires oxygen, right? So hemoglobin will carry oxygen from lung and will give to muscles and delivered it to myoglobin. Myoglobin there will store oxygen until it is required for metabolic action, and the hemoglobin then actually it does not bind to CO2, it binds to H2O. Hemoglobin, just think like it will carry oxygen from lungs to muscles, and it will carry carbon dioxide. It will deliver carbon dioxide from muscles back to the lungs, and and the storing function is done by myoglobin. This much is clear, right? So now in lungs there is high oxygen pressure. Hemoglobin will combine with oxygen. At high oxygen pressure, hemoglobin will combine, and then when it is coming to muscle, there is only low oxygen pressure. So at low oxygen pressure, what will happen? Hemoglobin will free the oxygen present, and this is stored by myoglobin. Okay, and this pH thing, no, that we will learn later. What is the role of pH? So then you will get it clear. So when even though the oxygen pressure is low, since myoglobin has more affinity towards oxygen, this will catch the oxygen which is freed by the hemoglobin, and then it will be stored in the muscle. Okay, now after this first part is done, were from lungs, the hemoglobin carried and delivered. The first part is done. So that high oxygen pressure, hemoglobin will bind with oxygen, giving HbO2. Actually, I should write 4 times because each hemoglobin will deliver 4 oxygen molecule. And low oxygen, that is in muscle, it will leave. Okay, this is the first part. Now, what will happen? How this carbon dioxide is transferred back to the lungs? In human body, 85% of carbon dioxide is transported as bicarbonate form. Bicarbonate. So, how it is done? The mechanism is given here. So, Hb, once it has released the oxygen, it will bind with water. It will bind with water molecule, and the carbon dioxide molecule will diffuse from plasma to hemoglobin, and then this carbon dioxide will combine with the water. So first what will happen? Hb will deliver oxygen. Now Hb1 place is free, the water will combine, and we will get the first part, Hb dot H2O. Now to Hb dot H2O, carbon dioxide will come, and what we will get? Hb dot H plus HCO3 minus. This is called as hemoglobinic acid. These two things happens in muscle. This is called as hemoglobinic acid. Okay, so these two things happens in muscles. Now this bicarbonate ions, whatever is present, will diffuse to blood plasma from hemoglobin, and the blood returns to heart through the veins, and it is then pumped to the lungs. And in the lungs, this HCO3 minus and H plus Hb will go back to H2O, CO2, Hb, and then CO2 is exhaled. Okay, this is the a whole oxygen transport activity that is happening in this. The basic things you already know, that hemoglobin, how, what it is carrying, myoglobin is storing, and only the mechanism will be like a little new for you, where it is actually binding with water, not with carbon dioxide, and forming hemoglobinic acid, and then the carbon dioxide is exhaled after reaching the lungs. Okay. Now, one important thing is that so there is a mechanism, cooperativity and all we will learn. So one important thing is that in oxymyoglobin or oxyhemoglobin, no, in deoxy state, first we will learn about deoxy state. If we have like porphyrin ring N, let me like draw simply N, and iron and histidine residue. So this iron will not be on plane. It will be a little bit above from the plane normally, like a square pyramidal shape it will be when it is in deoxygenated state. Fe2 plus deoxygenated state, it will be a little bit above. Okay, so how much above this is? This will be around 0.7 to 0.8 Armstrong. It will be above from the plane. In the reason, actually in my coaching class, they have told like the ionic radii is inversely proportional to CFSE. So in oxymyoglobin, CFSE is more because everything was below, right? So if we calculate the CFSE will be more, and the ionic radii is less in oxymyoglobin case, whereas in deoxymyoglobin it is opposite. But in book, whatever I have read is it is due to spin state. Okay, I can refer you one paper. You can go and visit that paper. In that paper, they have told the theories. It is from Chemistry Review, volume 25, number 4. You can visit that. In that, the actual reason they have given why this is happening. But I think for easy like memory and you should not get confused, I will tell that whenever iron is in high spin state, when iron is in high spin state in deoxygenated form, iron is in high spin state, whether it is myoglobin or hemoglobin. So whether it is myoglobin or hemoglobin, in deoxy form we saw it is high spin state. In high spin state, it is told that size increases by 28%. So when size is high, here there is a cavity, no? Iron cannot fit here. Iron will stay 0.7 Armstrong above. And iron nitrogen bond length that case will be 2.1 Armstrong. So square pyramidal, almost we will get the shape will be. Now when it become oxygenated, this is for deoxygenated, don't get confused. In deoxygenated we saw high spin, size increases by 28%. So iron will stay above 0.7 to 0.8 Armstrong above from the porphyrin ring system, not in a plane. But when oxygenated form, the low spin state means size decreases by just by 0.1 Armstrong. So we can tell that our whole life depends on this 0.1 Armstrong. So when size decreases from 2.1 to 2 Armstrong, this iron can come down. And now this iron will be properly fitted and we will get a planar structure in oxyhemoglobin state. Okay, so this is an important thing because questions can be asked how much above it is present or below, what will happen. And due to this thing only, like this this iron, whenever oxygen is attached to it, will size will decrease and will come to the planarity of porphyrin ring. And due to this only, we will learn what is cooperative effect. Like we have hemoglobin, so many hemoglobins are there present, imagine. So one iron has bonded with oxygen. So what will happen? It will size will decrease and it will come to the cavity. This will trigger the other iron atoms also to bind with oxygen and it will also come to the plane. So this is called as cooperativity effect. So this is the basics of cooperativity effect, from where it is coming. So if some questions is asked, what is cooperativity? What will happen in square pyramidal? Why square pyramidal? Why planar and all? These are the things. Okay. So if some question is asked, what is the iron nitrogen bond length in deoxy state? It is 2.1, where the size is more. 0.7 to 0.8 Armstrong, just 0.7 to 8 Armstrong, 0.75 Armstrong is more. Whereas in oxyhemoglobin or myoglobin, the size decreases and fit in the center of the porphyrin ring. This is the mechanism of oxygen binding. And whenever oxygen binds, this bind in this fashion, and this fashion is called as end-on fashion or bend-on fashion. In some cases, this will bind like this, and this is called as side-on fashion. So don't worry about this. Now we will learn about hemoglobin or myoglobin, and in that case, the angle is 130°. So, and this binding is called as end-on or bend-on fashion binding. Okay. Now, like I told in cooperative effect, so what will happen? I told you when one oxygen is binded with hemoglobin, we will get HbO2, right? So this will trigger the other hemoglobins to also bind with oxygen. And this will bind to next, and next. So the first one is little bit difficult. K1 is little bit difficult. But once when one oxygen is binded, the other will bind very fast. And due to cooperativity effect, that's why K4 will be high, then K3, K2, K1. This kind of question can be asked. They can give you the mechanism and ask which is high, K4, K3, K2, K1. So the answer is always the last one, due to cooperativity effect. Okay. So that is what is written here. Upon binding with one oxygen, iron becomes low spin and small in size. Hence, iron move towards the plane of porphyrin ring, and this makes binding easy for next oxygen, and this is known as cooperative effect of hemoglobin. This effect is not there in myoglobin. Okay, this is not only there in hemoglobin. Now, we have learned about what is myoglobin, hemoglobin, in which state iron is present, low spin, high spin, Fe2 plus, Fe3 plus, etc. So, we will solve some questions, and then we will see whether we are getting correct answers or not. So, this question was asked in 2012 GATE Chemistry 42. They have given that hemoglobin is an oxygen carrying protein. The correct statement about oxyhemoglobin is that. So, in oxyhemoglobin state, whether it is low spin or high spin?
Low spin, ma'am.
Low spin, correct. And the oxidation state of hemoglobin, oxyhemoglobin?
+3, ma'am.
+3, correct. And the dioxygen is attached in?
Superoxide form.
O2
Superoxide. O2 minus, correct, very good. So the correct option will be?
A, ma'am.
A, correct. Low spin +3 oxidation state, and the dioxygen is in O2 minus form. So you understood, no, what is the type of question that has been asked from hemoglobin and myoglobin. So once you know that, this will be very easy. And this does not take even 1 minute to answer. I think this was a 2-mark question also. Now similar question only. Oxymyoglobin and oxyhemoglobin respectively are? Whether they are paramagnetic or diamagnetic?
Paramagnetic, ma'am.
Oxyhemoglobin is diamagnetic.
Yeah, it is diamagnetic. Both oxyhemoglobin, oxymyoglobin, diamagnetic. Paramagnetic was in deoxygenated state where it was high spin. So, and in oxidated, when oxygenated form happens, like when oxygen is attached, in both myoglobin and hemoglobin case, it becomes diamagnetic, and deoxygenated case, both are paramagnetic. Okay, we might get confused because now itself, now only we started learning, there is no issue. It is just we have to like keep on reminding ourselves or read ourselves, then only we will not get confused. Both are diamagnetic in oxygenated state and deoxygenated state paramagnetic. Okay, if there is any doubt you can ask. Is this clear?
Yes, ma'am.
Okay, good. Fine. Okay. Now, 2 questions we have asked, we have answered, no? 2 more things, important things are there related to hemoglobin. How, like, various factors affect the binding efficiency of hemoglobin and myoglobin. So one factor is pressure, and the other factor we are going to deal with will be pH. And questions has been asked from this area also. So pressure, as you can all imagine, with the increase in pressure, the binding chemistry of hemoglobin as well as myoglobin with oxygen increases. But the increase is in different way, like both increases, but in MP, the increase is in like a parabolic curve, whereas in HB, that is hemoglobin, the increase is like a sigmoidal curve. So if they have not given this one and have just asked the graph, which one is for option, they will give A graph, B graph. A is for hemoglobin, B is for myoglobin, like that. They can give different option. So in this first point, we will not have confusion because increase in oxygen pressure means increase in binding. So how the increase is, we should not get confused. The first one is parabolic for myoglobin and hemoglobin sigmoidal pressure. That is easy. Now, the next important factor is effect of pH. And the effect of pH is called as Bohr effect. In myoglobin, there is no effect of pH. It is pH independent. So whatever pH they give and they ask, what will be the oxygen binding affinity of myoglobin in these different pH? It does not matter. pH independent myoglobin. But in case of hemoglobin, with decrease in pH, the binding capacity of hemoglobin with oxygen decreases. So this is called as Bohr effect. With decrease in pH, the binding capacity of hemoglobin with oxygen decreases. Now, in order to feed it in our system, we will learn just what happens in our tissue. Okay. So in tissue, what is happening? Glucose is glycolysis, decomposition of glucose is happening so that we get energy. So in that case, carbon dioxide is released, and the carbon dioxide is hydrolyzed to form H2CO3, which will be in equilibrium with H plus HCO3 minus. So here, as you can see, H plus. So concentration of H plus increases means more acidity, meaning pH decreases. So in tissues, we know that hemoglobin releases oxygen. This is a reason. pH is less there, and when pH is less, the binding capacity of hemoglobin is less, and this will help hemoglobin to release oxygen in tissues. And whereas myoglobin, which is pH independent, does not have any problem, and it will bind with that oxygen released by the hemoglobin. Okay, so now by learning this one, you will not have confusion, I feel. Okay, so in tissue, in tissue, we know hemoglobin releases. So in tissue, pH is less or more. It is less due to the formation of H2CO3, in fact H plus, and pH is less. So in pH is less means hemoglobin binding capacity is less. So this is called as Bohr effect. With decrease in pH, the binding capacity of hemoglobin with oxygen decreases. Okay. The pH of human body ranges between 7.35 to 7.45. This value we should know because questions has been asked. Okay. Now, one question is, at pH 7.2 and 10 torr oxygen partial pressure, the extent of O2 binding is. So 10 torr oxygen partial pressure means it is in a good partial pressure, right? So at high partial pressure, both hemoglobin and myoglobin will have high affinity to binding. So there is no confusion in case of partial pressure. It should be high for myoglobin as well as hemoglobin. But we have to check the pH. pH normally is 7.4. This is lesser than that 7.2. Myoglobin has no effect. Since high partial pressure means it will be high for myoglobin. But because pH is less, the oxygen affinity of hemoglobin decreases or increases? Decreases. Correct. So, the correct option will be myoglobin, it will be high, and hemoglobin, it will be low, decreases. So it will be low, and the correct option is option C, high for myoglobin and low for hemoglobin. Can you answer this question? This is
Can you
pretty
please,
strict.
ma'am,
Huh?
can you please explain again, ma'am, that questions cannot.
Yeah, sure. So we have two parameters, right? pH and partial pressure of oxygen. So partial pressure of oxygen is 10 torr, and in partial pressure means in both the cases, whether it is hemoglobin or myoglobin, with high partial pressure, both extent of oxygen binding is high. So if we don't consider the first part, pH, just consider the second part. If we consider the second part, what will happen? We will get high for hemoglobin and high for myoglobin. High myoglobin and high hemoglobin. We are getting like this. Okay. Now we have to consider pH. One more factor is the pH 7.2. Since myoglobin is pH independent, we should not consider anything regarding the pH. This is high. This stays high. Now we have to consider hemoglobin. The human body normal pH we saw earlier is 7.4. In 7.4, pH is optimal for hemoglobin. Now the pH is 7.2 given in the question. So when pH decreases, what Bohr effect tells that when pH decreases, the affinity of oxygen binding by hemoglobin also decreases. So from 7.4, the pH is decreasing. So the oxygen binding capacity of hemoglobin also decreases. That means this will not be high, this will be low due to low pH. So we will get high for myoglobin and low for hemoglobin. Is it clear now?
Yes, thank you so much, ma'am.
Oh, it's okay, fine. Okay. Now, next question. Among the pH value, the oxygen binding efficiency of hemoglobin is maximum at. Can you tell
0.4, ma'am.
what?
7.4.
7.4. Yeah, correct. Option D, because it is the high pH. So we don't even have to think for a second, right? If we know one simple effect, Bohr effect, we will get the answer very easily. How much our pH they have given, we just have to select the highest value. If they have given 8, just select that value. If they have given 7.6, we have to select that value, like the high pH value. So, okay, one more thing I will tell you. So these are the important factors about hemoglobin, myoglobin, and the factors, external factors that affect its oxygen binding affinity. Now, one important thing is the poisoning. Like the hemoglobin also, apart from oxygen, also interact with other ligands like carbon monoxide, cyanide, etc. And that's why these molecules are toxic. Okay, since because when once it is binded to cyanide or carbon monoxide, even if after that oxygen comes also, there is no use. It is already forming cyanomethemoglobin it will form, and this will lead to cyanide poisoning. That's why it is very lethal to us. So this can be asked. So it is why cyanide is poisoning, just because the hemoglobin has more affinity towards the ligands like carbonyl, cyanide, etc. And that's why it is poison to us. More than oxygen, this has ability to attach with carbon monoxide, PF3 cyanide, other ligands. Okay. Now, one more thing we will learn today is about hemocyanin. So once if we are completed with hemoglobin and myoglobin, so we should not get confused. Hemoglobin and myoglobin is done. Now we will be learning about hemocyanin. Okay. So in case of hemocyanin, not like the name, it does not have heme group, or it does not have cyanide group, but the name is hemocyanin. So I have seen question asking like which all among the 4 options given, which all contain heme group, and the options were hemoglobin, myoglobin, hemocyanin, hemerythrin. And in this hemocyanin and hemerythrin, both of it does not have heme group. Only hemoglobin and myoglobin has heme group. Okay, so hemerythrin I will teach you next class what is hemerythrin. So now we will learn about hemocyanin. Hemocyanin is a non-heme protein, neither contain heme group nor cyanide group. Now, what is the function of hemocyanin? It is involved in transportation of oxygen. It contains copper containing protein. Hemocyanin and hemerythrin both are used for transportation of dioxygen. And this, since it contains copper metal, it is called as blue blood. The color is blue, and the blood is called as blue blood in oxygenated form. In deoxygenated form, it will be colorless, and in oxygenated form, it will be blue color. So now we have, in this also, we should learn about 2 forms, deoxyhemocyanin and oxyhemocyanin. In everything, whether it is myoglobin, hemoglobin, hemocyanin, we should know about 2 parts of the particular protein, deoxy and oxy part. So in this case, the first one is deoxy and the second one is oxy one. So what all things they can ask from this particular topic? What is the oxidation state of the central metal atom? What is the central metal atom? First question, it is copper. In deoxy state, copper will be +1 oxidation state, T10 system. And in oxy state, the copper will be in +2 oxidation state. And also this distance can be asked. The distance between two copper metal atom is 460 in deoxygenated state, and it decreases to 360 in oxygenated state. And O2 exists in peroxide form, that is O2 2 minus form. In other cases, hemoglobin and myoglobin, it was superoxide O2 minus, and this is peroxide O2 2 minus. And in both case, it is diamagnetic. In copper 1, it is D10 system. There is no unpaired electron. So hence it is diamagnetic and ESR inactive. Whereas in copper 2, even though it is D9 system, same as oxyhemoglobin, there was anti-ferromagnetic coupling. Here also, due to coupling, the spin of one electron of one copper atom will be cancelled out by the spin of another electron of another copper atom, and due to which it will also become diamagnetic. So in both oxy state and deoxy state, this is diamagnetic and ESR inactive. The only difference is that first one is deoxy state is copper 1, oxy state is copper 2, and the attachment is peroxide. So they can ask myoglobin oxymyoglobin what is the attachment, and oxyhemocyanin what is the attachment. So the attachment is superoxide and peroxide. These are the questions they can ask from this particular hemocyanin part. So we can solve some 2 questions from hemocyanin part, and then you will understand that what are the type of questions that has been asked from this particular topic. So first question was asked in 2015 GATE chemistry 54th question. Identify the function of hemocyanin and metal responsible for it. Even though from hemoglobin and myoglobin, a little bit inside questions can be asked from hemocyanin, hemerythrin, etc. The questions will be pretty from the surface level, and it will be very easy. So if we know some basic things, you will be able to answer such questions. So in this, as we saw earlier, what is the function of hemocyanin?
Oxygen transport.
Yeah,
B,
correct.
option B.
Option B, correct.
Transport.
Oxygen transport. Yeah, correct. Very good. Oxygen transport, and the metal responsible is copper. Very good. You guys are really good listeners and good learners. So the correct option is option B, oxygen transport and copper. And the next question is, the oxygen coordinated to metal ion centers in oxymyoglobin and oxyhemocyanin exists respectively as. So in oxymyoglobin, what is the state in which oxygen is coordinated?
Peroxide.
Peroxide in
Superoxide and
Superoxide
peroxide.
and peroxide, ma'am.
Yeah, correct.
Option A.
Peroxide in oxyhemocyanin and superoxide in oxymyoglobin. So oxymyoglobin is the first one asked, so it is superoxide. Oxyhemocyanin is the second one asked, that is peroxide. So the correct option is option A, superoxide and peroxide. Okay, so now these are the basic questions that has been asked in the last like from 2012. I have gathered some questions regarding hemocyanin, hemoglobin, and myoglobin. And in next class we will learn about hemerythrin and plastocyanin, chlorophylls, etc. So one more important thing I will tell is, what is methemoglobin? That also I have seen in one question paper. So methemoglobin or methmyoglobin is that when we have seen iron present in +2, +3 oxidation state, etc. But when the oxidation state of iron permanently changes to +3 form, permanently. Otherwise, it can change to +3 and come back to +2. But if it permanently changes to +3 form, in that particular time, it is called as methemoglobin or methmyoglobin. This question can be asked. I have seen in some question paper, not in GATE, I think, but in some question paper, I have seen such question has been asked. So, methemoglobin, we should know what it is. Okay, so these are the basic things. I think we have carry all the important things related to hemoglobin, myoglobin, and hemocyanin. So if there are any other doubt regarding this, then we can discuss that. Or if it is fine, because these are just direct facts. So I think like this all maximum such kind of questions from superficial state only I have seen asking in question paper. So I think you should be able to answer such kind of questions if they are asked in the coming session. So are you clear with whatever we have discussed today?
Absolutely, ma'am.
Oh, thank you. Then it's fine. Okay. So then we will meet in the next class and we will learn a little bit more about bioinorganic chemistry. Even though I am not a biology person, this kind of things, bioinorganic chemistry is very nice to handle, like very easy marks gaining session. So only superficial level only we need to know also. So it will be easy for you to gain marks since it is our motto to qualify it. We will go in like mark gaining session and 1 mark question, 2 mark question and all. Okay. So next class. Bye. Okay. I'll.
Thank you, ma'am. Thank you so much.
Okay. Thank you. Thank you. Okay. Bye. Good night all.